So this is page 2. Number 5, symmetry. Use the regular square pyramid as shown. So I'm going to draw it out for you. First I draw the front face, front edges, and then I draw the back, and then here's the top, that's the back edge, the front edges, and one of the side edge. And it goes through the middle right over here. And you also have the lateral height L right over there. So I'm going to label these a little bit differently. That's your regular height, perpendicular to the ground. Call that H. And let's use pink this time. That's perpendicular. This is your lateral height L. So usually in most books, L, the letter L is reserved for the lateral height. Hope you can see all that. And they also give you some information right over here. The side is S. Of course, this is S2 because it's a square pyramid. And they give you L and H. And they also give you one more information, which is it goes along this way. So number 5, what is the lateral area? Well, we know that the lateral area, what kind of figure is this? It's a pyramid. So that's a keyword, pyramid. The lateral area for a pyramid is equal to 1/2 the perimeter of the base times your lateral height. And so you have here your lateral face, the right one, the front one, the left side, and then the back. That's equal to 1/2 the perimeter of the base is S plus S plus S plus S, which is 4S. Notice it's not the area. Area is S squared. It's 4 times S times the lateral height L. We don't know what that is. They just call it L. 1/2 of 4 is 2. So it's going to be 2SL. And there it is. I'm going to skip 6, 7, 8. Let's go to the next problem. It says a cylinder with radius and a height has lateral area. So we're looking at a cylinder. That's the keyword. And I use different numbers. The radius is equal to 5 in my case. Let's call it meters. And I put the height as 12 meters. What's the lateral area? Again, I'll read the question again. A cylinder with a radius of 5 meters and a height of 12 meters has a lateral area of what? What do we know? Oh, we know it's a cylinder. Let's draw it out. It's a soup can. And we know that cylinders have 2 bases, here and here. In other words, a cylinder is also a type of prism. So we're going to use the formula, the basic formula. The lateral area is equal to the perimeter of the base times the height H. The perimeter of the base happens to be right along here. It's not oval shaped, it's a circle shape. So it happens to be 2 pi r just for circles times H, that's equal to your lateral area. If you're not quite sure how that works out, I'm going to draw it for you a little bit nicer. And you notice that this, as you open up this label of the soup can, that portion right there becomes your circumference of this circle on top or the bottom. Or actually the top, doesn't really matter. So the lateral area is equal to 2 times pi times the radius, which is 5, times the height, which is 12. Notice I'm going to multiply the 2 and the pi first because it's easy. 10 times 12 is 120 pi. And it's going to be meters squared. There it is. Let's do the next problem. I did number 11. So here we go. A cone, this time, with radius is equal to 10 centimeters this time. Height is equal to 9 centimeters. And what am I looking for? I'm looking for the volume. Hope you can see that very well. Again, let me read the question. A cone with a radius of 10 centimeters and a height of 9 centimeters has a total volume of how many cubic centimeters? I changed the problem a little bit just so that, again, I'm here to help you out. It's your problem, not mine. No pun, actually, every pun intended. So good luck with your studies. It's for your exam, so you should be doing these problems by yourself and working them out. So the volume of a cone is equal to 1/3 the volume of a cylinder. And let me show you draw for you to show you how it works basically. So you have a cone. A cone is basically a party hat. And for most of you, you've seen these before. No, I hope all of you have been to a party. Birthday party, that is. And, you know, the party hat, that's what it looks like right over here. Except it has a base right here. It's usually solid. If you take this cone and you fill it with water, it'll fill up 3 of these cylinders. Or 3 of these cones will fill up 1 cylinder. So that's the concept formula. Volume of a cone is equal to 1/3 times pi r squared h. Because we know the volume of a cylinder is equal to the area of the base times your height. That's your concept formula. Area of the base is pi r squared times your height h. And that's where it comes from. So the volume is equal to 1/3 times pi times the radius is 10 times 10 times the height is 9. 1/3 of 9 is 3. 10 times 10 is 100 times 3 is 300. 300 pi cubic centimeters. Remember that volumes are in cubic centimeters. There you have it. Next problem. I did number 13. Let's read the question. It's a sphere. This time, that's a key word, sphere. And I put the radius as 6 centimeters, and I want the surface area. So let's read the question one more time. A sphere with radius 6 centimeters has a surface area, or the area, equal to question mark. I'm going to draw a sphere out for you just to make sure that you know what a sphere looks like. Oh, it's a ball. Think of it as a ball like this, you know, a regular ball. The surface on the outside, that's the area that they're talking about, the surface area. I'll show you an easy way to find the formula for the surface area. The area inside here through the diameter with the radius r, that's equal to pi r squared. So if you take 4 of these and you plaster them on the outside and you paint over it with this, the same amount of surface area, that's what you get. It's a crazy number. It's always 4 times the area of the circle. So the surface area is equal to 4 times pi times r, which is 6 times 6. 36 times 4 is 144 pi. I memorized that. 36 times 4 is 144, I think. Want to make sure. I try not to make a lot of mistakes. So